The orbits of the planets required another ingredient. This brought Newton back to the work he had begun 20 years earlier on gravity. To show how gravity works on Earth and in the skies, Newton designed a thought experiment. He imagined firing a cannon from the top of an extremely tall mountain. From his first law of motion, he knew the cannonball would travel in a straight line at a constant speed forever. But gravity pulls the ball downward. If its speed is low, the cannonball hits the Earth near the mountain. The higher the speed, the farther away the ball lands.
If you throw it faster, it comes farther away. Even faster, farther away. Even faster, it may go 1,000 miles. Even farther, it may actually go almost halfway around the Earth and there hit the Earth.
Newton imagined that if its speed were high enough, the cannonball would travel all the way around the Earth and settle into orbit.
The orbit of the cannonball around the Earth was a balancing act between the cannonball's tendency to fly off in a straight line and its being yanked back towards the center of the Earth continuously by the force of gravity. So in Newton's picture of the world, there were two things. The natural tendency of an object to travel in a straight line, which was true on Earth or in space or anywhere, and there was the attraction of gravity, which was true on the surface of the Earth, and it was true up in space.
Newton's breakthrough was to see that the moon's orbit around the Earth and a cannonball's motion on Earth were governed by the same law of gravity.
That is a beautiful way of persuading you, me, and probably his colleagues that cannonballs falling to the Earth and the moon falling to the Earth is one and the same law of physics, gravity. The moment that he realized that, almost everything else follows from that.
Newton reasoned that if gravity governed motion on the Earth and the moon, why not on Jupiter and its moons, which he had seen with his reflecting telescope? Why not the entire solar system? In a bold leap, Newton proclaimed that this invisible force operates everywhere in the universe.
It's an incredible leap. It's beyond anything anybody had imagined at the time.
Newton called it the universal law of gravitation, and he wrote it in one simple mathematical equation.
It's so important because it really tells us how nature operates in a fundamentally new way. Newton is saying the same thing that is going on in the heavens is going on Earth, and vice versa. It gives us a guidebook to answering the age-old question of what causes the rise and fall of the tides. It gives us answers to the orbits of the planets and their positions. It's a tremendous act of intellectual triumph, one of the great keystone, cornerstone pieces of our intellectual heritage.
It was a total revolution. The universal law of gravity was a complete revolution the way that we think about the world